Okay, radicals. So a radical is really a square root or a cube root. It's anything written like this, okay? And it could have any number right there. If it doesn't have a number, it's assumed it's a 2. So let's look at some perfect squares, cubes, and fourths. So those are perfect squares, perfect cubes, perfect fourths. Okay? And let's simplify these. This should be a review, but it's okay if it's not. So 252. So we need to break this down. So you could do it with a factor tree. I'm going to do it inside the radical this first time. And we're trying to find pairs, because really a square root, that means there's a 2 right there, right? So anytime you have 2 of something inside of there, we can pull it out. So let's see if we can get it so there is 2 of something. So 252, that's the same as 2 times 126. 126 can break down to 2 times 63. 63 can break down to 7 times 9. 9 can break down to 3 times 3. Okay, and if you multiply that back out, 2 times 2 times 7 times 3 times 3, you would get 252. Now we have to see, do we have any pairs here? Well, we have a pair of 2s and we have a pair of 3s. So I can pull out that 2, and I can also pull out that 3. And when you pull them out, they end up multiplying to each other. So that's going to be 2 times 3, which is 6, square root of 7. Okay, let's do this one. So negative 5 cube root of 128. Well, now a cube root, we're going to look at this the same way, except for now we're looking for 3. 3 numbers that are the same. Okay, and that number will always tell you the numbers, like however many you're looking for. So if there isn't a number, assume it's a 2. So 128 can break down to 2 times 64, which is 64 breaks down to 8 times 8, which both of those 8 breaks down to 4 times 2 and 4 times 2. Then those 4s break down to 2 times 2 and 2 times 2. So we have 2 times 2 times 2 times 2 times 2 times 2 times 2. It's a lot of 2s. But if we multiplied that back out, it'd be 128. Notice how my arrow moved? That was weird. Okay. But now let's find groups. So we have that group of 3 and that group of 3. So that means I can pull out the 2s, the purple 2s, and the blue 2s. And then we'll multiply it to the negative 5. So negative 5 times 2 is negative 20 cube roots of 2. Cool? Let's do this one. So 2 fourth root of 48. I'm going to do this one using a factor tree. I want to show you guys multiple ways so that you can decide, I hate it that way, I want to do it this way. Or hate's a really strong word. Let's not use that, actually. I disliked that way, I like this way better. Or, yeah, okay. So a factor tree, you should know these also. We're looking for 4 terms that are the same. So 48 breaks down to 2 and 24. 24 breaks down to 2 and 12. 12 breaks down to 2 and 6. 6 breaks down to 2 and 3. Okay, and you're only looking at the ends of the tree. Think about it like the fruit at the end of the tree. Yum. Fun fact, I have a pear tree, a plum tree, a grapevine, and all sorts of fun trees in my backyard. So that's probably why I put yum. Anyways, so we're looking at groups of 4. There's a group of 4 2s. So that's what I'm going to pull out. So it's going to be 2 times 2, fourth root of 3, which is 4 fourth root of 3. Okay? Do those next examples. And let's do this one. So adding and subtracting rationals. The first thing I always want you to do, and I'm going to write this big, always simplify radicals first. Simplify first. It will make your life so much easier, I promise. So, if we look at this, let's break down the 32. So that's 2 times 16, which is 4 times 4. So there's a pair of 4s, so I can pull that out. So that's going to be negative 20 square root of 2, and then plus 7 square roots of 18. Well, let's break down that 18. So 18 is 2 times 9, 3 times 3, pair of 3s, so I can pull that out. So I have negative 20 square root of 2 plus 21 square root of 2 Well, negative 20 plus 21, that's 1. Oh, yeah, and remember, so when you're adding radicals, you can only add them when they have the same term underneath the radical. Okay, if they're different, you cannot combine them. Okay, so negative 20 plus 21, that's just 1 squared to 2, which is the square root of 2. Okay, let's look at this one. So let's break it down first. Fun fact, you can have negatives under odd radicals, but you cannot have them under even radicals. Under an even radical, it's an imaginary number. So the square root of negative 1 is I. But the cube root of negative 1 is negative 1. Okay, so if we have the cube root, okay, so cube root of negative 56, well, let's break this down. So the reason we can pull out a negative 1 is because negative 1 times negative 1 times negative 1 equals negative 1. Because negative 1 times negative 1 is 1, times negative 1 is negative 1. That's because we have a group of 3 of those, so we can pull it out. Okay, and then we have 2 times 2 times 2 times 7. You could make a factor tree of that if you wanted to, and you would get, actually I'm just going to do it real quick. So 56, you would have 7 times 8, which is 2 times 4, which is 2 times 2. That's where those came from. And then these came from that negative. Okay, this is just showing you, oh, I can pull out a negative 1 there. Okay, so then I can pull out a negative 1 and a 2. So that's going to be negative 1 times 2 cube roots of 7, which is negative 2 cube roots of 7. Then let's break down the 189. Oh, sorry. And then multiply that by 3 and you get 6 cube roots of 7. And then cube root of 89, you get 3 times 3 times 3 times 7, which those 3's can pull out. If you don't believe me, then do it for yourself. I don't want to waste time doing that part of it, though. And then that's 3 cube roots of 7. So that becomes 3 cube roots of 7, which is 9 cube roots of 7. Okay? I want you to try and do H and J. Let's do this one. So multiplying. When multiplying and dividing, always simplify the radicals first. Okay? I promise it makes your life easier. So 18 breaks down to 2 times 3 times 3, which is 3 square roots of 2. And 20 breaks down to 2 times 2 times 5, which is 2 square roots of 5. Okay, so that's going to be, I'm going to just put in that 3 square roots of 2 where the 18 was, and the 2 square roots of 5 where the 20 was. So that's going to be negative 3 square roots of 2 times 4 square roots of 5. Then once the radicals are simplified, you multiply outsides with outsides, insides with insides. So negative 3 times 4 is negative 12, and 2 times 5 is 10. So that's negative 12 square roots of 10. The last thing you would do is check and see if the radical simplifies. 10 doesn't simplify, so we just leave it. Okay, let's do this one. So 7 square root of 3xy squared plus 3, 15x cubed y. Well, if we break those down, so 3xy squared breaks down to y 3x, and 15x cubed y breaks down to x 15xy. So if we put those where they are, that's going to be 7y square roots of 3x times 3x square roots of 15xy. That's going to be 21xy square root of 45x squared y. Now, I have a hunch that that probably simplifies, so let's simplify it. So that's going to be 5 times 3 times 3 times x times y. The 3's can be pulled out and the x's can be pulled out. So that's 3x square roots of 5y. We're just going to multiply it by that, which is going to end up being 63x squared y square root of 5y. Okay? I want you guys to try L and M. Then let's get into multiplying and simplifying these radicals. So multiplying, you can use distribution or the box. It's the same as what we were doing when we were multiplying polynomials. So 5 times 7 square roots of 2 is 35 square roots of 2. 5 times 1 is 5. And then negative square roots of 2 times 7 square roots of 2 is negative 7 square roots of 4. And negative square root of 2 times 1 is negative square root of 2. Well, I know that we can combine, I skipped some steps right here, We can combine these two to get that 34 square root of 2. 5 just stays, and then the square root of 4 is 2. Which simplifies further. Down 7 times 2 is 14, so that's 34 square root of 2 plus 5 minus 14, which 5 minus 14 is negative 9. I want you to try and do P. Remember that the square means that there are 2 of them. You will still multiply in the same way that we did this example. Okay. So rationalizing denominators. So if there is a monomial in the denominator, you just multiply by the radical. So that means if there's just one term, no plus or minus between them. But say there's a binomial in the denominator, then you multiply by the conjugate. And I already wrote, what the heck is a conjugate, right? A conjugate is formed by switching the sign between the terms in a binomial. Okay, so it's just, if it's a plus sign in between them, you change it to a minus. If it's a minus sign between them, you change it to a plus. So the conjugate of A plus B would be A minus B. Okay, those are conjugates. So let's look at this one. So 6 square roots of 480 over 2 square roots of 6. Well, simplify first. Always simplify first. It makes your life easier. So that breaks down to 2 times 2 times 2 times 2 times 2 times 3 times 5, which is 4 square roots of 30, which is 24 square roots of 30 over 2 square roots of 6. Well, that 24 over 2 can simplify to 12, so that's 12 square roots of 30 over square root of 6. Now, this is a monomial in the denominator. So now we're just going to multiply both sides by the square root, or top and bottom by the square root of 6. Then we multiply. So 12 square roots of 180 over the square root of 36. The reason we multiplied by that 6 on the bottom is because we created a perfect square right there so that you are just left with a 6. Okay, we did that on purpose. Which 12 over 6 simplifies to 2. But now let's make sure that this 180 is broken down as far as it can go. So that's 2 times 2 times 3 times 3 times 5, which is 6 square roots of 5. So that's 2 times 6 square roots of 5, which is 12 square roots of 5. Okay? Let's do this one. Always simplify first. Okay? So negative 32, negative 1, 2 times 2 times 2 times 2 times 2, which is negative 2 cube roots of 4. Now, we have negative 2 cube roots of 4 and 2 cube roots of 4 on the bottom. Those can cancel each other out, and you're just left with 7 times a negative 1, because when those cancel, it just leaves you 1. So that's where you get this negative 7. Cool? Now let's look at this one. So always simplify inside first if you can. So 288 divided by 2 is 144. J to the 7th divided by j squared is j to the 5th. And then k to the 4th divided by k is k cubed. And then we can just break down that radical. So that's 2 times 2 times 2 times 2 times 3 times 3. We have 5 j's and 3 k's. So I have 3 2's, 3 j's, and 3 k's. So I can pull out a 2, I can pull out a j, I can pull out a k, and I'm left with 2 times 3 times 3, which is 18, and then j squared. Okay, I want you to try TUND. And let's look at this one. So this is that weird conjugate one. So the conjugate here, you just change the middle sign. So that's going to be negative 1 plus the square root of 5. Negative 1 plus the square root of 5. On top is easy because you just multiply. So that'd be negative 4 plus 4 square roots of 5. The bottom, use distribution. I'm just going to use the box so that you guys can see this a little clearer. Negative 1 times negative 1 is 1. Square root of 5 times negative 1 is negative square root of 5. Negative 1 times square root of 5 is square root of 5. And square root of 5 times negative square root of 5 is negative 5. So those cancel and you're left with 1 minus 5, which is negative 4. And then we can divide. 4 goes into both of those. So that's really 1 minus the square root of 5. Cool? try x. Let's get into this one. So this is just going back and forth between radicals and exponents, because a radical can be written as an exponent. So a to the m over n power is the same as n square roots of a to the m. So if you just remember that the top number is on the inside and the bottom number is on the outside. So if we look at this, so 9, or p to the 9 over 2 is the same as the square root of p to the 9th, which is just square root of p to the 9th. You don't have to write that 2 right there. Whew, that looks kind of ugly. So 27 to the 1/3, r to the 17/3, and s to the 8/3. Well, let's just write this out. So we have the cube root of 27 times the cube root of r to the 17th times the cube root of s to 8th. Well, we can just write that all as one thing. Except for I did not do that. This is not what I wanted you to do. So at this point, see how these are all cube roots? Cube root, cube root, cube root, cube root, cube root. Sorry. So this is going to be the cube root of 27 times r to the 17th times s to the 8th. And then what I did in those steps is I was simplifying further. So the cube root of 27 is 3. The cube root of r to the 17th, so that goes in 3, 6, 9, 12, 15, 5 times, so that's going to be r to the 5th. And then s squared, and you're left with r, so this was 15 of them, so you're left with 2 in there. And this was 6 of them, so you're left with 2 right there. Okay, this answer right here is what I was looking for, though. Okay. You can follow that if you want to. This one, we're going to go back to our exponent. So we have 5k cubed to the 4th root of that. So that's going to be, remember, the k is the only thing being cubed there. If it's not in parentheses, the k is the only thing being cubed. So that's going to be 5k cubed to the 1/4 power, which you could then distribute that in. So that'd be 5 to the 1/4 times k to the 3/4. Okay, this one, see how that one, the whole thing's in parentheses? So that's going to be 4y to the 3/2 power. Okay? We are saving the rest. Try to do them if you want. Yeah, I'm really sorry. Yeah, you guys are super awesome. Bye.